Now, throughout this material, we will be referring to many different kinds of functions, and all of those are going to be easy to understand if you have a very good understanding of the basics. And now there are some additional topics on functions that I wanted to go over. There's a notion of increasing and decreasing function. Now, what we're trying to do here is characterizing the relation between, the goal is to characterize the relation between input and output. Okay, that is between x and y. Now, recall from the review videos something called trichotomy, which is a very simple observation, yet a very fundamental nature of numbers, is that given two numbers, a and b, one of three things is true. A is less than b, a equals b, or a is more than b. So that is what is going to be used to define. So this fundamental idea plays a very, very important role, or has very, very important consequences. Now this is how. Now let's say I want to draw a function f of x. I have a freedom of drawing the picture as I want to draw. Now, I'm going to zoom in and look at, say, specifically between inputs 2 and 3. Let's say at 2, my input was 1. Yeah, so f of 2 is 1. Now f of 3 is some number. Let's say I call it a. And the question is, what are the choices for a? Now, of course, there are infinitely many choices for a. But can I characterize these choices in a way that it reflects this trichotomy? And I can. Yeah, so the choices for a is either less than 1, or a is equal to 1, or a is greater than 1. Right? It doesn't give me a lot of information about the function, but it does tell me, for example, either, so the three cases, right? Either I can have here, they're equal, or I can have somewhere here, or I can have this be somewhere here. Now let's say I bring this point 3 closer. Yeah? If I bring it closer and closer to 2, then what's going to happen is that I can either have a case where this goes up, or it goes horizontal, or it goes down, which gives the obvious definition of increasing decreasing function. Namely, if I take a function and it's like that, so if x1 greater than x2 implies fx1 greater than fx2, it's called an increasing function. If fx1 greater than x2, x1 greater than x2 implies that fx1 less than fx2, then it's a decreasing function. Okay, so this blue function is increasing, whereas this red function is decreasing. How do I see that? Is if you go along this x-axis, the output, which is the height, keeps on increasing. Whereas if I go along the x-axis here, then this height keeps on decreasing. Okay. Now, these are actually going to have to change this as strictly increasing or decreasing functions. Okay. Strictly meaning because they cannot be equal. So if they are equal, then they are not strictly increasing, then they are just increasing or decreasing. You know what? me make some space here. Come back to this later. So what I mean is that let's look at some examples. So if I have a function that goes like that, and then goes like that, and then goes like that. So over here it's constant, say at 2. So this is not strictly increasing, but we can still call it increasing. Okay, because so the condition for increasing is x1 greater than x2 implies f of x1 greater than or equal to. Okay, but you can still have what is called intervals of increasing / decreasing. So it's kind of like if you look at this graph, then you notice that in all these values of x until here it is increasing. Then between these values of x to these values of x it is constant, and then from this value of x to all other values it is increasing again. So in an interval notation, or this information can be captured by saying it is increasing in, again we use the interval notation, negative infinity to well, I gotta assign some value to this point. Let's say this is 1 and this is 5. So it's increasing in negative infinity to 1 union 5 to infinity, and constant in the interval 1 to 5. Now if you pause for a minute and think about it, any diagram you draw can be classified in this form. Yeah. So whatever you draw, if I draw something like that, this is say 7, this is 5, and this is -3. So you see at some point this function is increasing along, and then it decides to decrease, yeah, and then increases again. So in this area right up to here it's increasing, and then in here it is increasing, but in between it decreases. So in this case we say the function increases from so it's increasing from negative infinity to 3 union 4 to infinity, and it's decreasing from 3 to 4. Yeah. In fact, over here we can say it is strictly increasing and strictly decreasing. So what you can do is you can draw some diagrams of just random functions and convince yourself that you can always sort of classify a function as increasing, decreasing, or constant, and that itself, that phenomena, is a consequence of trichotomy of numbers. So it's a very simple idea which leads to important consequences. And later on in this course, we're going to see that this results in ideas of finding maximas, minimas, and all. Okay, I'm going to end this video, and it's going to be one more video where we talk about some standard functions.